Guys, welcome back to my math YouTube channel. I'm back with another example on solving trig equations. Guys, let us look at this example number 8. So on the left hand side, I have 10 sine square x minus 12 sine x minus 7 equals to 0. And we want our final solution, the values for x, to be between 0 and 360 degrees. Guys, the left hand side looks like a quadratic form. So I think whenever we have a quadratic form, we should try to start by looking for the factors. If we cannot use the factors, then one has to use some other method. Because guys, we know our goal first is to isolate sine x. And just by looking at the left hand side, we cannot just directly isolate or evaluate for sine x. So one has to use some methods. In this case, first we try to use the factoring method. Guys, using the factoring method, we know we start by multiplying this 10 with this negative 7. We got a negative 70. Then we have to try to come up with two factors for negative 70 that add up to negative 12. So I'm not going to actually write all those factors here, but guys, if we try finding those two factors, we are not going to be able to find those two factors for negative 70 that add up to negative 12. So what does that mean? That means we cannot really factor this polynomial on the left hand side. So if we cannot factor this quadratic polynomial, then one has to use some different methods to solve for the sine of x. So guys, in this case, we are going to use the quadratic formula. So to use the quadratic formula, let me quickly remind you the basic steps. Guys, step number 1 is to identify the a, b, and c, because those are the three quantities that are required for the quadratic formula. So the variable a would be 10, positive 10, and b would be negative 12, and c is negative 7. First of all, I'm going to write the general form of a quadratic formula, which looks like x equals to. So if it is for x, if I am working with a standard quadratic equation of the form ax squared plus bx plus c, then we are solving for x. So it is negative b plus n minus square root of b squared minus 4ac divided by 2a. Well, that is the standard formula, right? In this case, we are not only interested in, we cannot just directly solve for x. First, we have to solve for sine of x, because it's not just x squared and x, it's sine x squared and then sine x. So to evaluate sine x, I just have to basically evaluate this or use this formula. Negative b, guys, negative times negative is going to become positive, right? We can simplify some of the things right away in this step. And then there's plus and minus. Then let us see what is left inside this radical. Then we have a square root of b squared, negative 12 squared. If you simplify, you get 144. And then there's a minus 4ac. Guys, c is negative 7. So it is negative times negative will become positive. And when I multiply 4 times 7 times 10, what do I have here? So I get a 280 for this piece. Guys, this whole thing has to be divided by 2 times a, which is just simply 20. Let us go ahead and simplify this. So this is going to be 12 plus and minus square root of, we're going to add this. It's 424 divided by 20. So then after this, we got to simplify. Square 424 is not a perfect square, so we will use a calculator, and I used a calculator on this. This is what I have. I have 12 plus and minus square root of 424. I said 20.5913. Guys, I went to 4 places. If you don't want to go up to 4, if you want to just only go up to 2, that's fine as well. But I went up to 4, so divided by 20. Now from here, we can clearly see that there is going to be 2 solutions. There's a plus and there's a minus. So when I use the plus and minus, this is what I got. Sine of x equals to, so guys, using the 12 plus, I got equivalent to 1.6296. That was one of the solutions for sine x. And then the other one that I got was sine of x. For that one, I used the minus 12 minus. Obviously, I'm going to get a negative value, and that is what I got here. A negative 0.4296. Okay, so guys, let us focus on these two now. Obviously, guys, this is a decimal. These both are decimals. We cannot see them on a unit circle. So again, we have to rely on a calculator. And it's not too complicated calculators. Most of the calculators have an inbuilt inverse function, so we just have to simply use the inverse function on the calculators. But before using that, guys, let us first look at this first equation. Guys, this says the sine x is 1.6296, but we already know that sine cannot exceed positive 1 because the range for the sine function is between negative 1 and positive 1. It cannot exceed positive 1 and it cannot go any further, any below than negative 1. So it has to be between negative 1 and 1, although the endpoints are also included. So that means since this is not possible, so for this equation we have no solution because we already know that sine cannot exceed positive 1. And now let us look at this equation. Now looking at this equation, obviously this is between negative 1 and 1, so this is a valid value for sine function. The other thing, we already know that sine is negative in the third and the fourth quadrant. So let us make a quick note of this. So to find the x for this particular equation, we should already remind ourselves or let ourselves know that the x will be, the angle will be either in the third, it will be in the third or the third and the fourth quadrant, right? Now again, we cannot just find this angle from a unit circle. We are going to use the inverse key from a calculator. So you guys, using the inverse key, this is how we are going to actually use the inverse key. So x equals to sine inverse. We have to apply the inverse of the sine to get x by itself, which is the sine inverse. And then in the parentheses, basically you have to just type in this negative 0.4296. And when you use your graphing calculator, or if you have a simple calculator that should also have a sine inverse key, guys, this is what we get when we do sine inverse of this angle. We get a negative 25.44 degrees. Now guys, this is what we get when we use the inverse key. But now we want the final answers to be with positives, right? We don't like the negative angles. So we have to, like, once we have this, we have to kind of transform this and make sense out of this and transform it into positive angles, which is not going to be too difficult because we already know that this negative is basically, they're measuring it in the clockwise direction below the x-axis. So guys, this is also thought of as a reference angle. So this is like my reference angle. In this case, we cannot just simply say that this is the value for the angle or this is the value for the x. We have to do some extra work. And guys, that was one of the reasons why I chose this problem. Number one reason was that this is the problem where we cannot factor, so we have to use the quadratic formula. So I wanted you to see, like, sometimes we have to use a quadratic formula. We cannot just always factor these things. So that was one of the reasons why I chose to show you this problem. And the other reason was that, hey, we cannot use the unit circle. We have to use the graphing calculator, or we have to use the calculator, and we have to use the sine inverse function. Once we get the answer for x from a calculator, that is not the actual answer. That is like a reference angle. Now we are going to do some extra work to figure out the actual answers for this values for this particular function, or the solution for this function. Guys, keep in mind, we already know that the final answer or the values for x are going to be in the third and the fourth quadrant. Now this reference angle is going to help us to find out those angles. Guys, how I like to do it from here is I like to draw those quadrants, and then this negative 25.4 for this reference angle. I already know that this is in the fourth quadrant, somewhere right here, right? This is back my negative 25.44 if I measure from like this in a clockwise direction, right? But since we are interested, we know that it's in the fourth quadrant and the third quadrant, and we want to measure angles in a counterclockwise. So that means we are measuring, and we consider this as our reference side. So if we are measuring the angle in the counterclockwise direction, so we're this terminal side will make this angle, right? And this would be the angle in the positive direction. That would be the one of the solutions of this particular equation, which in turn is a solution of this equation. Now we already know that the total angle that it completes in one complete revolution is 360. So to find this much, we just have to subtract 25.44 from that, because that is my reference angle right there. So for one of the values in the fourth quadrant, keep in mind we'll have two values. In the fourth quadrant, to find the value for x, you just have to do 360 minus this 25.44. Guys, I always like to draw this once I have my reference angle, and that helps me to evaluate the angles in the in the counterclockwise direction. So when we subtract this from 360, this is what we get. X equals to 334.56 degrees. That is one of the values, but we already know that sine is also negative in the third quadrant. How are we going to find that angle in the third quadrant? Guys, it is not too complicated. We already know that this reference angle is 25.44 bit. You can think of this reference angle in all the quadrants, although we don't have to worry about the first and the second because it's a negative value. We only have to focus on the fourth and the third. So how do we get this other angle? Guys, we know it has to be a reflection. They are symmetrical, right? These things are symmetrical. It's a periodic function and these things are symmetrical. So we got to have a reflection. We got to think about a reflection of this side or this terminal side on the third quadrant. So it is going to look something like this. And obviously this angle is also going to be 25.44, right? So if this angle is 20.44, then the actual angle, the measure of actual x, again measured from the reference side, this is going to be from here all the way up to this terminal side this time, right? Keep in mind, guys, they have to be symmetrical with respect to the y-axis. We are not worried about the first and the second because it is negative. Otherwise, we could have done the same thing in the first and in the second quadrant as well. Okay. Once I have the reference angle, I draw that terminal side, and then I use the idea of like the measuring angles in the counterclockwise direction, and also the idea of symmetry because these things have to be symmetrical. So guys, to find this angle, which I have tried to label or identify with this red marker, guys, we know already from here up to here the angle measure is 180, so we just have to add that 25.44 to get the final angle, and that would be my other angle in the third quadrant. And we already knew that we were supposed to get two angles, one in the fourth and one in the third. So that would be 180 plus this 25.44, and when I add these, I think it's going to get 205.44 degrees. Guys, these are the two values. This is one of them, this is the second one, and in this case we were not able to find any solution. So guys, one has to do some extra work and extra steps. First of all, when one cannot factor the polynomial, the quadratic function, and also when one cannot see these angles or these values, sorry, on the unit circle, then you have to use a calculator, and the calculator may not give you both the answers, and calculator may not give you the answer the way you want it. So you have to make sense out of this. But once you already have an understanding of the unit circle, and also the understanding that a sign is positive in first and second, and all, I mean, you have to know all the basic things before you can actually figure out the final values for the x. Guys, this is number 8. I will see you next time with number 9. Till then, take care.